Today we're going to talk about multiple transformations of parent functions. When we were in class today, we looked at a couple of transformations when there was a vertical shift and a horizontal shift both. But right now we're going to be talking about some shifts along with stretches both in the horizontal and vertical direction. So when you have many transformations of a parent function, it is very important that you follow the correct order. Okay, the table of XY values changes with each transformation. So you might have up to 4 XY tables with a single function. Maybe something has shifted to the right and it's been stretched and then it shifts down and then it's been stretched in another direction, or maybe it's been reflected. So you could have, like I said, up to 4 XY table of values, but the order is very important in which transformation is done first. So the order in which transformations are done is very important. And you are going to follow this order. Okay, the first thing you're going to do is horizontal shifts. In other words, you're going to add or subtract from the X values in the table. The second transformation, if you have one, is going to be a horizontal stretch or shrink or reflection. In other words, you're going to multiply or divide the X values. So the first thing you're going to do is work with the X's, and then you're going to work with the Y's. The next thing, if you have a vertical stretch, or shrink, or reflection, that's done third. And with those, you're going to multiply or divide the Y values. And then the last thing you're going to do is a vertical shift, which adds or subtracts from the Y values in the table. Okay, and how I remember this is I remember things alphabetically, if I can. So H comes before V alphabetically, so I'm doing things horizontally first, vertically second, or in other words, X comes before Y alphabetically. So we're going to change the X's first, then we're going to change the Y's second. And then as far as the stretches and shrinks, I remember that these two match, numbers 2 and 3, the stretches and shrinks match, and then the shifts match on the outside. So horizontal first, vertical second, and then inside here they match up this way. 2 matches with 3 and 1 matches with 4. So let's do some examples. Let's graph y is equal to 2 times the absolute value of x minus 4. So what we have here is we have a vertical stretch because the 2 is on the outside, and then we have a vertical shift. So we have two things that we're going to do: vertical stretch and a shift. So the first thing that we have to do, if we do it out of order, we're going to get wrong. We're going to get a wrong graph. So first we're going to vertically stretch this, and then we're going to vertically shift it next. So I'm going to do the table of values. First we do the parent function, so -2, -1, 0, 1, and 2. I won't do the 3s just for speed. Okay, so there's the parent function. So the first thing we're going to do is we're going to double the y's because that's what the 2 on the outside of the function means. So my new xy table becomes the x's don't change, and then now the y's double. So you have 4, 2, 0, 2, 4. And then the next thing you're going to do is this vertical shift. So that means you're going to take this y table and subtract 4 from it because it's a shift down of 4. So now our final xy table is the x's stay the same, and the y's you subtract 4, so you get 0, -2, -4, -2, and 0. And then you can just graph that on your, let's see, it looks like everything is underneath the x-axis. So I can put my x-axis up high here. And we go from -2 to +2 on our x-axis, and -2, 0, and 2, 0, -1, -2, and 0, -4, and then right on back up again. So here's our first. And if you wanted to try to do this in reverse order, if you wanted to try to subtract 4 and then double the y values, I don't think that's going to work correctly. So there's your first one. Here's your second example. Let's graph y is equal to negative square root of 2x. So we got a square root parent function this time. So to start out with our xy table, remember we have 0, 1, 4, 9, and 16, the perfect squares. And then let's see what we have. We have 3 things going on. We have a vertical reflection on the outside of the function, and then on the inside we have a horizontal shrink because this 2 is greater than 1, so we're going to be dividing the x's by 2. So this is a horizontal shrink because of this 2x, and it's a vertical reflection. So we're going to do the horizontal shrink first, vertical reflection second, and in this case I don't really think the order matters, but we'll just keep this order the same anyway, or how we explained it before. So the first thing you're going to do with the horizontal shrink is you're going to take all those x's and divide it by 2. So you have 0, 0.5, 2, 4.5, and 8. And then the y's stay the same, 0, 1, 2, 3, and 4. So this is x divided by 2 is the first transformation. The second thing you're going to do is negate the y's. I don't think I'm going to draw a new xy table because to negate the y's, all you have to do is make those values negative, and that's a lot faster. So we got actually just 2 xy charts that we need. So it looks like the y values are all negative, and x's go out to 8. So we'll make a longer x-axis. Will go out to 8, 4, 2, 6. And 0, 0 is the start. 1, 2, 3, 4. 0.5, -1 is about there. 2, -2 is here. 4.5, -3. And 8, -4. And remember, square root functions have an arrow on one end, but it has a definite start. It doesn't have arrows on both ends. And if you ever wanted to check your answer with a calculator, you can just plop it in. Y equals negative square root of 2x. And I'll zoom 6. And there's your function, just like what we graphed. Next example we're going to do, we'll do 2 more and call it a night. Next thing we'll do is y equals 2x minus 4 squared. So we have a parent function of a quadratic. So we'll set up our parent function -2, -1, 0, 1, and 2, and square them, 4, 1, 0, 1, 4. Okay, what we have here is we have 2 horizontal transformations going on here. We have a horizontal shift of 4 of this, we're going to be adding 4 to all of our x's. And then we have a horizontal shrink, which means that we're going to be dividing all of our x values by 2. So let's take a look at what happens here. Remember, we do the horizontal shift first, so we're going to do x plus 4 first. And that means that we're just going to add 4 to all of these. So we have 2, 3, 4, 5, and 6. And the y's don't change. And then the second thing we're going to do is the horizontal shrink, which means we're going to divide all of the x's by 2. So all of these x values get cut in half, which is 1, 1.5, 2, 2.5, 3, and the y's don't change. And then if we wanted to graph this, see, it looks like everything is above the x-axis here, and the x's go from 1 to 3, and the y's go up to 4. 1, 2, 3, 4. So we start out with 1, 4, 1.5, 1, 2, 0, 2.5, 1, and 3, 4. So here's our beautiful quadratic function. Let's check to make sure we're okay on this. Y equals parentheses 2x minus 4 parentheses squared. And I'm going to set my table of values. I'm going to start it at 1, and I'm going to go up by 0.5 because that's what my x table goes up by, just to make sure that my table of values is right. So we have 1, 4, 1.5, 1, 2, 0, 2.5, 1. So everything looks fine. And there's our beautiful shrunk horizontally. So this is a thinner graph than normal. And then the last example is, we'll do another square root function. Y equals negative square root of negative x minus 1. Lots of negatives here. So we have 3 different transformations going on here. This negative on the outside of the whole function, this is called a vertical reflection. That's that negative right there. You might want to mark it. This is the vertical reflection. On the inside, because it's right next to the x, this is a horizontal reflection. All right, mark that. Mark this as the horizontal reflection. This is the vertical reflection. And then this minus 1, that's a horizontal shift. So what order do we do these in? If you remember, it goes alphabetically. We do horizontal shift first, horizontal reflection second, and vertical reflection third. So we're going to set up 3 xy tables here. First, starting with the parent function of 0, 1, 4, 9, 16. 0, 1, 2, 3, and 4. There's your parent function. So like we said, the first thing you're going to do is a horizontal shift. So you're going to be adding 1 to all those x values. So it becomes 1, 2, 5, 10, and 17, but the y's stay the same. The second thing you're going to do is a horizontal reflection. So that means you're just going to negate all of the x's. So then, I'm not going to waste my time by putting a new one in. Then I'm going to do a negative x. So I'm going to take all of these and make them negative. And then, to save time, we'll just do a negative y because we have the vertical reflection. This means negate all those y's. So those are going to become negative 2. So we have those ordered pairs, negative 1, 0, negative 2, negative 1. So it looks like our x values are going all the way out to negative 17. And our y's are all going to be underneath the x-axis. So we'll go a long way this way. Let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18. Negative. So our first point is negative 1, 0, which is right here. Our second point is negative 2, negative 1. The third point is negative 5, negative 2. let's see, 2, 4, 5, negative 2, negative 10, 2, 4, 6, 8, 10, negative 3, and negative 17, negative 4. So it starts right here on the x-axis and it's coming back in this direction. All right, so I'm just going to make sure that I'm okay with that. Y equals negative square root of negative x minus 1. And I'm going to look at the table of values starting back with a negative 17 on my x values, and I'm going to go up by ones. So negative 17, negative 4, that's the correct one, correct point on my line. Then we're going to go back to negative 10, negative 3, that's correct. Negative 5, negative 2, that's correct. Negative 2, negative 1 is correct. And negative 1, 0. And then the rest are out of the domain. So there's my graph. And it kind of looks like what we just graphed. So make sure when you have multiple transformations, you do it in this strict order here, or else you're probably going to have some of your values in your table of values done incorrectly. And that's it for today. See you tomorrow.